Okay, so these are the notes for 2-5 on compound inequalities. So a compound inequality is formed when two inequalities are joined by the words and or the word or. Okay, so think of that word compound. Think of what it means to be a compound word, like two words joined as one. The same thing goes for inequalities. We have two inequalities that we're bringing together, and they are classified by being an and inequality or an or inequality. So what that means is for it to be an and inequality, it would have to satisfy both parts of the inequality. For it to be an or inequality, it could satisfy one inequality or the other. So for graphing these on a number line, if it's written all as one inequality, like number 1 and number 2, these are both and inequalities. And the last one would be an or inequality because it has that word or in it. So typically you won't see the word and for and inequalities, but you will see the word or always for or inequalities. So how we read and inequalities is we start in the middle and then we work our way out. So we say x is greater than or equal to -1 and less than or equal to +2. So when we go to graph these, we want all of those values included in our number line. So the smallest value is -1. So I'm going to start my number line with -2. I like to try to have at least one value extra on each end of the inequality so that when you go to shade, your shading represents the solutions and you can determine possible solutions just based on the shading alone. So I'm going to do a quick sketch and then I'll formally graph it in a sec. So start from the middle. So we have x is greater than or equal to -1. So what that would look like is it would be a filled in circle at -1. And it's greater than, so we would shade to the right. Now the other part of the inequality is it also needs to be less than or equal to +2. So that would be a filled in circle at +2 and less than would be shaded to the left. So for and inequalities, it's the shading that's overlapped because it has to satisfy both sides of the inequality. So where it overlaps is right in the middle. Okay, so those values that are shaded, -1, 0, 1, and 2, those values satisfy both parts of that compound inequality. All of those values are both greater than or equal to -1 and less than or equal to 2. Okay, so you don't really need the purple part here. That was just to kind of show you where they overlap, but you can just shade just right in the middle of the two values. Okay, let's do another one. So we want values from 2 to 5 on our number line. So let's start with 1. Okay, and work your way inside out. So x wants to be greater than or equal to +2. So that would be filled in at 2. Greater than would be shaded to the right. Okay, it also needs to be less than 5. So that would be open at 5, less than is shaded to the left. Okay, so where these values are both true, where these inequalities are both true is in the middle where those shadings overlap. Okay, so what you'll find is 99.9% of the time, unless it's a special compound inequality, which while we're remote, we're not going to be doing special types of compound inequalities. Those would include all real numbers or no solution. So we're always going to have a solution while we're remote, just to keep it a little more simple for you. So compound inequalities for and, they're always going to be shaded in the middle. Because it's where they overlap. So for them to overlap, they would have to have these commonalities where they're shaded. For or inequalities, you graph them separate because it's this or this. So we need values from -3 to -1 on our number line. So let's start with -4. Sometimes these values are going to be a little further apart, so you might need to skip numbers, like increase by 2 or 3. And then or inequalities are graphed separately. So x needs to be less than -3. So that's open at -3, shaded to the left. Or x needs to be greater than or equal to -1. So that's filled in at -1, shaded to the right. I always think of or inequalities are the graph kind of looks like oars on a boat where they're shaded in the tails of the number line. And then if we just think about the words and or, so and there's going to be fewer possible solutions because it has to satisfy both parts of the inequality. So think of if we were talking about you all as a class, and I was trying to find the number of students that were wearing jeans today and a white shirt. That's going to be very few of you. But if I was trying to count the number of students that were wearing jeans or a white shirt, that's going to be more possible solutions, and they don't need to overlap. It's just one or the other. So for you to be a solution to those parameters, you would need to satisfy just one part and not both parts like the and compound inequalities. All right, let's go move. Let's now use those graphs and let's write these compound inequalities. So with ands, you want to start with the smaller value on the left, the larger value on the right, put x in the middle, and then fill in the inequality symbols. So for 6, for it to be shaded to the right, it would have to be greater than or equal to. And for 10, for it to be shaded to the left, it would have to be less than or equal to. You could also write it as two separate inequalities. You could write it as x is greater than or equal to 6 and x is less than or equal to 10. But try to write it like this first way here. One little trick or one little helpful little tidbit for and inequalities is if the smaller value is expressed on the left and a larger one on the right, the inequality symbols are always going to be both facing the left. So they're both going to be facing the same direction. And if it's smaller on the left, larger on the right, they're both going to be facing to the left. Or inequalities are a little easier to write because we just write them separate and include the word or. So for the left side here, we have x is less than 7, or x can be greater than 9. Okay, for 6, so we have x is less than or equal to -2, or x is greater than or equal to +2. Okay, so think if they're shaded in the tails, it's an or inequality, and think of like oars for a boat, for a little canoe. This or that. For and inequalities, remember, so start with the smaller value on the left. Just write it as you see it on the number line. Larger value on the right. Put x in the middle and then fill in the inequality symbols. For this middle part here to be where the shadings overlap, we would have had to shade to the right for -3. So that's greater than, and it's not equal to because it's an open circle. And for this to be the overlap, we would have had to shade to the left for +1. And it's filled in, so it's less than or equal to. So again, if the smaller value is on the left, the larger is on the right, both inequality symbols are facing the same direction, and they're both facing to the left. So if they're facing like different directions, that would be a sign for you to check to make sure that you have expressed the inequality correctly. Or maybe you didn't like flip the inequality symbol because you divided by a negative. They're all kind of telltale signs that something is a little off, and it's an opportunity for you to go back and check. Okay, so that's writing inequalities. So we graphed them, we wrote the inequalities from the graph. Now let's move towards solving inequalities. Okay, for and inequalities, our goal is to get x isolated in the middle of the inequalities. And because we have two inequality symbols, we essentially have three sides of the inequality. So what we do to isolate x in the middle, we have to do to both the right side and the left side to keep it balanced. So with number 8, right now to x, we're multiplying it by 2. So we have to divide all 3 parts by 2. If at any point you divide by a negative or multiply by a negative, you would still flip that inequality symbol. So for our number line, we need to express at least from 2.5 to 4. Let's just start at 0. That's a skill in itself, is getting your number line so that all these values will fit. So we have 2.5 is open, 4 is filled in because it's equal to. And you can almost just jump right in and just shade in between, but just to make sure. So x is greater than 2.5, less than or equal to 4. So yeah, it would be the values in between 2.5 and 4, including 4 because it can be equal to. Okay, so you don't necessarily even really need these arrows, but it just kind of shows how we're getting the shading in between, and it's because it's where the two shadings overlap. Okay, so now let's do a two-step. So we have 6x minus 1 in the middle. So our first step would be to add 1 to all three sides. I tend to just wait till the end to fill in the inequality symbols, but you could certainly fill them in as you go. But I just kind of follow the line and fill them in at the end. Okay, so we've added 1 to all three parts. Now we're multiplying x by 6, so we want to divide all three parts by 6. Okay, so let's just use increments of a third because both reference values are in terms of a third. Let's start with negative 2/3. Then we'd be at 0, 1/3, 2/3, and 1. But you could certainly just use integers and then estimate where those values would be. As long as you have the solution, the graph can be somewhat of an estimate. So it's filled in at negative 1/3, open at 2/3, greater than or equal to 1/3, negative 1/3, less than 2/3, so it's those values in between. Because you can almost always count on if it's and or an and inequality, it's going to be shaded in between those two values. That's where they're both true. For OR inequalities, you just solve them separately, the same way you would solve a simple inequality, a one-sided inequality. So solve 4x minus 2 is less than 2, and then solve 2x minus 3 is greater than 7. And then we graph them on the same number line. So first we would add 2, and then we would divide the inequality on the left by 4. For 2x minus 3 is greater than 7, we would first add 3. And then we would divide both sides by 2. The only difference is we need to include the word or to solve the compound inequality. So our number line, we want values from at least 1 to 5, but we want at least one extra on either side. So let's start with 0. Plenty of room to get from 0 to 6. And then on the number line, we graph them separately because it's an or inequality. X is either less than 1 or X is greater than 5. So from the number line, if I asked, is X equals 6 a solution? And we would say, yes, it is included in the shading on the number line. Is X equals 2 a solution? No, it is not. It is not included in that shading. Okay, let's do one more or inequality. So again, solve these separately. So 2x plus 4 is less than negative 6. We would first start by subtracting 4. We have 2 times x, so we would divide both sides by 2. And for the inequality on the right, we want to move the constant to the right side, so we would first subtract 5 because it's positive. So we have negative 3 times x is less than or equal to negative 9. So because we're multiplying x by negative 3, we want to divide both sides by negative 3. So it's that step there. Remember, this rule still applies. We divided both sides of that inequality by a negative number, so we just have to flip that inequality symbol. So it was less than or equal to, it's now going to be greater than or equal to positive 3. So with that being said, if we had to divide by a negative number for an and inequality, we would want to flip both inequality symbols because we divided all 3 sides by that negative number. So if you divide by a negative for an or, you just flip that inequality symbol. If you divide everything by negative for an and inequality, and it's expressed all together, then you would flip both inequality symbols. Remember, you're at the end, you really want to check to make sure if you have the smallest value on the left, the largest value on the right, that both inequality symbols are facing the same direction, and it's almost always to the left. That's one way to check at the end to make sure you did it correctly. So in this case, we want values from -5 to 3 on our number line. So let's increase by 2, and let's start at -7. You could label your number line however way you want, as long as it's increasing, meaning going from smallest to largest. So x is less than -5. So that would be open and shaded to the left. And x is greater than or equal to 3. So if we hadn't have flipped it, right, if we kept it as x is less than or equal to 3, the shadings would have been kind of in the same direction. So that would also be somewhat of a red flag for this or inequality. Okay, let's do one word problem where we're just expressing the inequality as a compound inequality. Or sorry, expressing the situation as a compound inequality. And one correct the error problem. You are a New Hampshire state trooper who is assigned to work traffic enforcement on Route 101. The posted minimum speed is 45 miles an hour. And the posted maximum speed is 65 miles an hour. We want to detect vehicles that are traveling outside the posted speed limits. So we want to write these conditions as a compound inequality. So I was kind of confused a little bit on if I wanted to express the compound inequality based on who is following the speed limit or who would get pulled over. So I opted to just express it for both so that you would kind of see the differences on an and inequality and an or inequality. So if the maximum speed is 45 miles an hour, sorry, the minimum speed, that would be all values greater than or equal to 45 miles an hour. For them, if you can travel up to 65 miles an hour, if that's the maximum, that would be all values less than or equal to 65. So I decided to break this up into two inequalities. One, I'm going to express people that are following the speed limits, and one, people that aren't following the speed limits. So people that are following, that you wouldn't get pulled over, you could be traveling anywhere from 45 miles an hour to 65 miles an hour, including 45 and 65. So let's put the smaller value on the left, the larger value on the right, x in the middle. So let's express here. So the minimum, right, x is greater than or equal to 45. And x is less than or equal to 65. So if you're traveling between 45 and 65, including those two endpoints, including 45 and including 65, this would be your compound inequality expressing the possible speeds. So those that aren't following the speed limit, those that are traveling outside those parameters, would be anyone who is going less than 45 miles an hour. Right? That's too slow. That's dangerous. Or it would be anyone who is traveling over 65 miles an hour. Okay, so that would be the difference between an and inequality, is that there's like the values between something, or an or inequality would be values that are outside a certain range of values. And you would get pulled over if you were going too slow or if you were going too fast. And then for an error correction problem, we've got our buddy Joe Schmo solving this or compound inequality. We want to find, describe, and correct the error. So let's just start from scratch here. So in or inequality, we solve them separately. So we would add 2. So he's got that correct. For the inequality on the right, we would subtract 8. He's got that correct. He's got the word or. It looks like his error, he graphed it as if it were an and inequality and not as an or inequality. The or graph, so x is less than 10, would have been shaded to the left for negative 10, and x is greater than 5 would have been shaded to the right. Okay, so he solved it correctly, but he just graphed it as if it were an and inequality as opposed to being an or inequality. Okay, so that's it for the notes for 2-5 on compound inequalities.